Hello everyone, this is lecture number 29. Last class we just introduced the concept of influence line diagram and demonstrated through one example, a simply supported beam and also a cantilever beam. What we will be doing today is we'll demonstrate the influence line diagram with few more examples. Okay. And now the first example we will consider is this. Okay, this problem you remember we have considered this problem in some of the previous previous classes. This is a cantilever, this is a propped cantilever beam, but we have an internal hinge at C. Now let us, so what we have to find out? We have to find out here what is the influence line of support reactions at A and B, and influence line for shear and moment at D, which is at a distance B from at any arbitrary distance B from point A. Okay, so this is the problem. This is the problem. Now we can see that there are three segments AC, CD, and DB. Now what we consider influence line, we need to consider three cases. One is influence line when the unit load is between A and C, and then C and D, and the third case is between D and B. C is the internal hinge, so we know that moment at C is equal to 0. Okay, and we also know that it is a statically determinate problem. Okay, let us draw three separate cases. Okay, now first is the influence, the unit load is on AC. So we divide this problem for each case. We divide the entire beam into two parts. One is AC and one is CB. So first this is AC and this is CB. Okay, this is AC, then CB. So what are the forces? Our unit load we have on AC, which is at a distance x from A, right? And what are the support reactions? We have AY and then moment at A. Again horizontal reactions we are not writing, and then this is CY, and since it is hinge and CY is shown when belongs to this part, it is shown downward, it will be shown upward here, so that the hinge remains in equilibrium, and that is all. So this distance, this is A, this is C, somewhere it is D and it is B, that is, and at B we have another reaction force, that is By. Okay. So this is the free body diagram of when the influence line, when the unit load is between A and C. We'll apply the equilibrium condition on free body diagram, but let us draw consider other two cases as well. So again this is the case, this is case. Now we have, this is AY, this is MA, this is CY, BY, this is B, this is D, this is C, and this is A. Okay, and suppose the unit load is between C and D. So this is the unit load which is at a distance x is always measured from A. Okay, so that we use the same origin, same reference coordinate. Now let us consider the third case when the unit load is between D and B. Consider this, and then third case, again draw this is reactions AY, then moment MA, this is CY here, BY, and this is B, this is D, this is C, this is A, and the influence in the unit load is here, which is at a distance A, x from x. Okay. So we consider three cases. What we have done is we divided the beam we have the beam is broken at point C, since we have an additional condition at point C is moment at C is equal to 0, it is internal hinge. So, this is part AC and this is part CDB, and for this, and then we can have three cases are in unit load is between A and C, then CD and then DB, and these are corresponding free body diagrams. Now, what we will do is we apply the we'll apply equilibrium conditions on this. Now, let us first check this. Now, by applying the equilibrium condition this, we can say that there is no load in between C and B. So, CY, BY both are 0, right. So, we can say BY is equal to CY is equal to 0 from this. Okay. Now, if CY is from this free body diagram. Now, let us see this free body diagram. Now, CY is equal to 0. So, what are the forces? Only vertical forces we have, AY and 1. AY acting upward, 1 is downward. So, naturally AY will be 1. Okay. And if we take moment at A, CY is equal to 0. So, moment will be 1 into x. This is clockwise direction, this is sagging moment, and we can, if we equate them, so we get MA is equal to minus x. Okay. So, this is support reactions. So, BY. Now, let us find out what is the shear force and bending moment at D. You see, if you consider this free body diagram, the shear force at D will be 0. And similarly, because there is no load in between, so Vd is equal to 0, Vd is equal to Md is equal to 0. So, this is for this part. From this free body diagram, we have these expressions. Okay. We have these expressions. Okay. Now, let us consider this case. If we again consider this free body diagram, apply the equilibrium condition, summation of vertical forces is equal to 0, summation of moment at C or moment at B is equal to 0. Though what expression we get is, you please verify that By is equal to x minus, we know how to do this, right, and then By is obtained, and similarly we can calculate Cy is equal to 1 minus x minus A by L. Okay. This we can obtain by applying the free body diagram on this part. Okay. Now, once we know Cy, let us go to this free body diagram. Let us go to this free body diagram, and what we can say is that there is no other vertical load. We can say that AY is equal to CY, and if we take moment about A, then the moment A will be CY into this distance is A. This distance is A, this is L, A, this is A, this is entire distance is L. Okay. So, if we do that, then we get AY is equal to CY, or we can AY is equal to CY, we can write. Okay. CY is equal to this. So, let us find out moment, and moment will be minus AY into A, and the value of moment will be then MA will be minus 1 minus x minus A by L into A. Okay, into A. This is moment. Okay. Now, once we have the moment, now let us find out what is the Vd and Md here. Again, we can draw free body diagram of dB and calculate the, apply the equilibrium condition and get the expression for Vd and Md, and the expression we will get is Vd is equal to minus By, and which is equal to minus x minus A by L. By is equal to minus x minus A by L, and Md will be, I am just writing the final expression, Md will be By into this distance will be L plus A minus B. So, this value will be x minus A L plus A minus B by L. So, this is MD. So, this we obtain the entire part, this we obtain from this Fibonacci diagram. What we have is, we have By is this and Ay is this, we know Vd is this and Md is this. This is the final thing we need. Okay. So, these are all function of x. Now, let us consider this. Now, if we look at these two free body diagrams, then expression for By for this case and this case will remain same, and therefore, expression for Cy for this case and this case will remain same. Now, since Cy is same, the expression of Ay and My for this case and this case, they will also same. So, what is the expression for support reactions for when the unit load is between C and D and the unit load between D and B, in both the cases expressions for support reactions, they will remain same. Only change will be the moment at D. Now, how to determine moment at D? Again we apply the same concept and find out moment. The expression for moment will be, now moment will be first Vd will be 1 minus x minus A by L. I am not doing this calculation, this is the final result I am writing, because we have done this exercise many times in previous classes. Now, Md is equal to, we will get B minus A into L minus x plus A by L. So, this is the expression for shear force and bending moment when at D, when the load is between D and B. Now, let us draw the influence line diagrams. Okay. Now, first draw the influence line diagram for say Ay. Okay. Now, what is expression of Ay? Ay is equal to 1 when, for the first case, when the load is between A and C, and then all other cases Ay is equal to this, it is linearly varying. Okay. And at x is equal to, if we substitute x is equal to A plus A, means at B this Ay becomes 0. So, up to this is A, then C, D, B, influence line becomes up to C, it is constant, which is value is 1, and then 0, and this value is 1. This is for Ay. This is influence line diagram for Ay. Similarly, let us draw influence line diagram for By. What is the value of By? If you check, By is equal to 0 when the load is between A and C, and By is equal to x minus A by L when the load is between C and D and D and B both, means between C and B the By varies as x minus A by L. So, if you substitute at x is equal to L plus A, means at B, so this becomes 1. So, By is equal to 0 up to C, and then at B it becomes 1, and between this it varies linearly. So, this is 1. So, this is for By. So, this is for influence line, this is the influence line diagram for By. Let us draw it for another support reactions, means Ma. This is again A, C, B. Okay. Now, what is Ma? Ma is minus x between A and C. So, at C these values becomes minus A, and then between C and D, unit load between C and D, Ma varies with this expression. Okay. So, if you substitute x is equal to L plus A, means at B Ma becomes 0, and if you substitute x is equal to a here, then ma becomes minus a. So, this is the continuity of ma is maintained. If you substitute x is equal to a here minus a, here also it is minus a. So, influence line for this becomes, for C it is this and then linearly varying, and this value is minus a, and this is a, then C, B. So, this is for AMA, influence line for AMA. Similarly, let us draw influence line for shear force at D and bending moment at D. So, this is what is the value. Now, shear force at D when load is between A and C is equal to 0, shear force at D varies like this when load is between C and D, and shear force at D varies like this when the load between D and B. And if you draw them, then the expression what you get is, this is A, this is C, this is D, this is B. The expression you will get that this, and this value is minus B minus A by L, and this value is 1 minus B minus A by L. If another important check is the absolute value. If you add them, their absolute value will be 1 in this case, because only applying load downward is 1. Okay. So, this is for VD. Now, similarly, if you draw the shear force bending moment diagram, between A and C it is 0, just now we checked, and then it becomes this value, and this is A, C, D and B. This value is B minus A into L plus A minus B by L. This is for bending moment diagram, bending moment at D. So, these are the influence lines for support reactions and bending moment at D, okay, for this problem. Okay. Let us once again, please, I have not done all the calculations, because these similar calculations we have done many times. So, please verify these results yourself. Now, let us quickly go to our second example. The second example is this. We have again a simply supported beam with an overhang like this. Now, then what we need to find out? We need to find out what are the influence line for support reactions, and then what is the at any intermediate point D, what is the bending moment and influence line for bending moment and shear force. Let us slightly change this value is not L, make it more general. Say this is A and this is L fine, and let us take this D is at a arbitrary distance B, so that the influence line what we get is more general. Okay. Now, again we need to consider three cases. When influence line is here, the unit load is between AD, then DB, then BC. Okay. So, quickly draw the free body diagram of each cases. This is the first case where influence line is this is AY, and then this is BY, A, D, BC, and influence line is unit load is 1 here, which is at a distance, this distance is x. So, this is case 1. The second case is this, where this is AY, this is BY, B, D, A, C, and the unit load is between D and B, and this distance is 1 x. Okay. And quickly take the third case. Third case is this. Draw the free body diagram. This is AY, BY, C, B, D, A, and unit load is applied on this, which is at a distance x from this. Okay. Now, these are statically determinate problems. So, individually we can find out what is the reactions by applying equilibrium condition. We can determine what is the reactions A y B y, in this case A y B y, and the reactions will be in this case A y is equal to L minus x by L, and B y will be x by L. In this case A y will be L minus x by L, and B y will be L my x by L. And the third case, it says A y will be L minus x by L, and B y is x by L. So, what we can see is in all the cases your support reactions are same. Okay. Please verify this. Okay. These are all support reactions. Okay. Now, we need to find out what is the bending moment at shear force at point D. So, if we take the free body diagram of this part, so we have A y, and at D we have V d and moment M d, and unit load is 1 at a distance x, okay, and this distance is B. Okay. Now, similarly, if we for this case take the free body diagram of same part, the free body diagram will be, there is no unit load here, it is just only A y and then V d M d. There will be no load because load is now d b. This is A and D, A D A D, okay, and third case also same thing. This is A y, this is V d, this is M d, and there is no load in between. This distance is B, this distance is B. Okay. Now, what we need to do is we need to apply free body diagram. We have equilibrium condition here, equilibrium conditions here, and equilibrium condition here. And if we do that, then what are the expressions we have? We can find out what is the expressions for M d, and in this case what would be the expression for V d? V d will be, in this case V d will be A y. In this case also V d will be A y. A y already we obtained here. In this case also A y we already obtained. And what will be M d? M d will be A y into B. M d will be A y into B. Okay. And here also M d will be A y into B. A y already we have determined. Okay. And we can also apply in this case in this case M d and V d. So, what is expression M d and what is expression for V d? I leave it to you find out the expression, because it is very simple. We need to apply the boundary conditions only. We need to apply the equilibrium conditions only. Now, once we do that, we have the expressions for all these required forces, right? Now, let us draw the influence line for shear force, influence line. Let us first draw the influence line for A y. So, this is A, then D, B, C. So, what is A y? A y is L minus x by L, and that is true for all. So, if we substitute x is equal to 0, then it becomes 1, at x is equal to L, it becomes 0, and then x is equal to L plus A, it becomes minus A by L. So, influence line becomes at x is equal to, this becomes 1, at B it is 0 and it is linearly varying. So, this becomes 1 and this becomes minus A by L. Okay. So, this is the influence line for A y, this is for A y. Okay. Now, let us draw influence line for B y. What is B y? B y is x by L here, x by L here, x by L here. X is equal to 0, then B y is equal to 0, and after that it is linearly varying. So, it varies linearly, and x is equal to L, it becomes 1. So, this value becomes 1 and this value becomes L plus A by L. So, this is B y. Okay. Now, let us draw the influence line diagram for bending moment at D. We have the expression for bending moment for D. Now, this is A, D, B and C. Now, just plot those expressions that you have obtained, and what we will get is this is for bending moment, and these values will be, this will be minus A B by L, and this will be L minus B by L into B. Okay. This is for M D, and finally, we get shear force. Just plot the expression. One expression we have not determined. Please find out that and check these bending moment, these influence line diagrams. These become this, and then there is a sudden jump here, and then again this becomes this. Okay. Now, this is, these values are minus B by L, this is minus B by L, and this is minus A by L, and this is L minus B by L. So, these are influence line diagram. This is for MD, this is for VD, BD. So, this is the influence line diagram for support reactions and shear force and bending moment at any particular location D for this problem. Okay. Now, one thing you might have noticed that the influence lines are essentially, since it is just a concentrated unit load moving through the along the length of the beam, your influence lines are always piecewise linear. It means that your influence line always a collection of some lines. Okay. So, therefore, what you need to, the variation is always linear. That is what I wanted to mention. So, what you need to find out, if you know the points, you know the value of the influence line between at 2 points. So, in between that you can just join them and get the influence line. Okay. So, these are some examples, but again if you go through books, and there are many examples given, some solve examples, some exercise problems. Please do that and make yourself comfortable with the influence line. Okay. Now, what we do next is, next class is, what we have done so far is we discussed if a unit, a concentrated load is moving through the length of the beam. Now, instead of concentrated load, if the load is distributed load, a distributed load moves. So, then how that should be considered, and what are the important aspects that that may affect the not may affect, that may be that we need to consider, that we will discuss in the next class. Okay, thank you. See you next class.